Hey there, Algebra 1. Mr. Catlin here, helping you out with Lesson 3 Cool Down. And we got another one of these patterns that has all of these squares. We're finding the area as we go. So one of the best things to do as you're looking at these patterns is to kind of track the number of squares that are in them. That'll help you determine really what's happening. So we got 2 in this one. We got 4 plus 2, which is 6 in this one. We got a 3 by 3, which is 9, plus 3 is 12. So this is the growth that we're witnessing for this particular pattern. And it wants us to write an equation that represents the relationship between the step number and the number of squares in the pattern, and briefly describe how each part of the equation relates to the pattern. Okay, so the first thing that we notice here is they're not going up by 4 every time. Like plus 4 doesn't work. So we know because of that it's not linear. And we look at it and we say, well, times 3, and then 6 times 3 would be 18. It's not exponential because they're not multiplying by a common factor. There's this growth that seems to get bigger as we go from left to right, but it's not getting bigger as fast as an exponential function, and it's not growing as slow as a linear function. It's somewhere in between, which is where we find these quadratics. And what we're noticing about these quadratics are this shape of a square continues just to pop up. Like we got a square here, and we got a square here, and we have a square here. And so what's happening that relates the step to the square is the step number is the side length of the square that's growing from 1 to 1. So like the next one in step 4, if we were to draw it, step 4 would have a 4 by 4 square, which we'll draw real quick. There's a 4 by 4 square. And then instead of tacking on 3 to 1, it looks like they're adding a little row of however many steps that you've done. So down here at the bottom, they're going to tack on another 4 units like we saw it do here and here and here. So it looks like they're growing in square size by step number, side length, 1, 2, 3, 4, right? 4 in its side length, which gives you a 4 by 4 square, which is equal to 16 plus 4. And so the next one would have had 20 in it. So we can see that the growth is plus 4, plus 6, plus 8. It's growing at a nonlinear fashion. It's not multiplied by the same thing, but this is the nature of a quadratic because of the square aspect. So the equation that we see for this is, to find out whatever the value is in the pattern, you take the step, whatever it may be, we'll call it n, you square it, you multiply it by itself, 1 times 1, 2 times 2, 3 times 3, 4 times 4. And then after you square it, you add the extra little part that's being tacked on, which in this case is not the same thing over and over again like we've seen in some examples in class. They added 1, they added 2, they added 3, they added 4, right? We're kind of looking at this extra addition. The amount that they're adding is the step number, plus 1, plus 2, plus 3, plus 4. So that would look like this. All right. And whenever we talk about how this briefly relates to it, what we can say is this part right here relates to the square side length, right? Like the side length of the square. And this right here relates to the length of the row that's being tacked on, which is also the step number, right? Which is why we're also calling it n. So the square side length n, which is also the step number, the step number. Okay. We're squaring it because it's being squared because it's a square, right? Showing you the area that's inside the square. And we're adding into it because we're adding those individual number of blocks, whether it be 3, 4, 2, or 1, or whatever. Is this relationship between the step number and the number of squares quadratic function? Explain how you know. Yes. All right. And what we've noticed when we have a quadratic function, we always see that there is either a number being squared. Yes, there is a number being squared multiplied by itself in the expression for a quadratic. That is what we've been noticing. A quadratic. Wow, my pen's like losing battery or something here. It's struggling. Sorry for the poor handwriting. Yes, there is a number being squared or multiplied by itself in the expression for a quadratic function. That's what we're noticing. If we see this, or we see something like this, which is really the same as what we just have, if we see a number being multiplied by itself or a number being squared, it's going to be a quadratic function, and it's going to have this type of growth rate that we're witnessing in these patterns of these geometry shapes of squares, rectangles, and whatnot. And that should get you caught up on what we've been doing in class so far. We will continue to look at these patterns and build more quadratics as we start comparing them to exponential and how they're different tomorrow. Later.